Welcome, ladies and gentlemen. Today we're going to talk about inscribed angles. You're going to need that yellow chart, that half piece of paper that I gave you. You're also going to need your notebook out, a pen and or pencil, and a calculator. Let's get started. Alright, ladies and gentlemen, this right here has to go into your notes. Central angle, angle that has its vertex at the center of the circle. Now, this diagram is from our notes from the other day, but this is the kind of circles that we were talking about. At the center, and then we would know that our measure of angle C is congruent to the measure of arc AB. This is what we have been talking about. So most important on this page is that you get this definition. If you would like to get down the picture and the measure of angle C is congruent to the measure of arc AB, you may also do so. Alright, now what I need you to do is grab out your chart because we're going to fill in our first part here. Now it's really important, we're just working on the part that says inside the circle, and we're going to be working with this one, 2 radii at the central angle. That's very, very important. Because when we say central angle, we're talking about the center of our circle right there. So we're going to have to draw this picture in, and we're going to draw in 2 radii. Okay, so we're going to talk about this angle, right, our central angle, and we're going to talk about our arc. So we know that our angle equals the measure of our arc. So that's very important. We're going to have to put that down in our notes. So on your half sheet yellow paper, make sure you put that down, okay? All right. Now, the other day we've been talking about what our angles are when we are at the center of our circle. Now what we're going to talk about today is what our angles and our arc measures are going to be if we are on the circle instead of at the center of the circle. So, this is what I would like you to have down in your notes now. Now we're going back to our notes. An angle and its intercepted arc. So you have to have this picture for me, please. We're talking about an inscribed angle. So this angle right here, and an intercepted arc, which is going to be this arc right here that's intercepted by those 2 rays. Now, this part we do not have to have in our notes, but we want to look at this example here. If I look at this example, I want to know how many degrees are in the intercepted arc. So if I'm talking about the intercepted arc, that's from A to B. Well, if I tell you that A to C is our diameter, well, we're going to say this is 180 degrees. Now, if we want to think about the angle, if we're talking about this angle B right here, we're not going to go, oh, that's 180. It's not going to be the same anymore, ladies and gentlemen. When we look at this one, we're going to see, oh, this is probably, to me, it looks like a right angle, probably half. So probably about 90 degrees. Now I'm going to show you how we figured this out. So this part is very pertinent that you get into your notes, please. The measure of an inscribed angle is equal to half the measure of the intercepted arc. So you want to have that down and this picture. Okay? So the measure of angle ADB is equal to exactly half of the arc AB. I personally like to think about it like this, so if you want to write it like this down too, measure of ADB equals the measure of arc AB all over 2. That's how I like to think of it. Also a little thing, an angle inscribed in a semicircle is a right angle. So just like that last example we were looking at. Please make sure all of this gets into your notes, please. Alright, once you have that in your notes, you're going to want to change on over to that half piece chart. And we're going to work on this part of it now. We're going to do on the circle two chords. Okay, these are the ones we're going to work on. So we have a point on the circle, and we have two chords coming off of the circle. So it's going to look like this. Now in our definition here, we're going to put angle equals our measure of our arc divided by 2. Okay? So now this is our example. Make sure we have this on our chart, please. All right, we're going to do a couple of examples and then we'll be done, ladies and gentlemen. Here's our first example. So back to our notes again. We need to find the measure of angle C. So if we look at this one, I need to find the measure of angle D first. So if I look, here's my measure of angle D. And I'm going to extend out my line so I know what I'm working with. I need to find this. My arc measure is 100. So to find my angle D, I'm going to go back to what I learned. Angle equals the arc length divided by 2. So the measure of angle D equals 100 divided by 2, which is just 50 degrees. So the measure of angle D equals 50 degrees. Now, I want to find the measure of arc AB. So arc AB is right here. Now, when we first look at this, we're like, oh, we don't have an angle to work with. But what we do know is from D to B right here is a semicircle. So that's 180. Now, we can find A to D. So first, if I find the measure of arc AD, which would be, now we're thinking the other way around now. Now I know my angle, so I have to take my angle, which is 35 times 2. So if I know my angle, I need to take it times 2 to find my arc, which is going to be 70 degrees. Now, if this is 70 degrees and the whole thing is 180, to find the measure of arc AB, I'm going to take 180 minus 70, which will give me 110 degrees. So the measure of arc AB is 110 degrees. All right, moving on. Here we go on this example, ladies and gentlemen. This note needs to be put in to our notes for sure. It's a great example, and I'm going to have a special note that we need to put at the end. So, what is the intersected arc of angles J and K? So if I look at this one, here's J, and here's K. Now the arc that they share is ML. So they share the arc ML. Now if we look at this, what is the intercepted arc that angles L and M? So now if I look at L, here's L, and here's M. The arc that they share is JK. They share the arc JK. Now, if we're thinking about this, you can make a conclusion. If we think really hard, we can conclude that if two inscribed angles of a circle intersect the same arc, then the angles are congruent. Please, 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 ladies and gentlemen, this has to go into your notes, okay? Very important. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. All right, moving on to our very last example, and we'll be done for the day. So we're going to want to get this in our notes. We need to find the measure of KN and the measure of K angle KMN. So first we'll start with the measure of KN. So from here to here, Now I know my angle here is 52, so the measure of KN equals 52 times 2, which is going to equal 104 degrees. And that, ladies and gentlemen, is my answer. So if I know my angle, to find my arc, all I have to do is take it times 2. So I know this is 104 degrees. Now I need to find the measure of angle KMN. So KMN. Well, if we look here, this shares the same arc, so there's two ways. We know that arc is 104, so we could take the arc, 104, divided by 2, and we could get 52 degrees. Or we could just know, because they're sharing the same arc, that angle KMN is going to be the same as angle KLN, which is 52 degrees. All right, ladies and gentlemen, that is all that I have for you wonderful people today. I hope you go out and enjoy the wonderful, fabulous day ahead of you, and I'll see you later. Bye.